Hello everyone. This video is to show you how to use Excel to calculate normal distribution probabilities. To show this, we're going to use Chapter 6, Problem 6.41. And that problem says, on weeknights, the average number of hours of sleep per night for adults ages 55 to 84 is 7. Assume that this random variable follows a normal distribution with a standard deviation of 1 1/10 hours. So we're going to fill in our mean of 7.0, which Excel changes to just 7, and our standard deviation is 1.1. The questions we want to answer are, what's the probability that a person will get 6 hours, more than 6 hours of sleep? What is the probability that a randomly selected adult from this age group will get fewer than 5 hours of sleep? What's the probability that someone randomly selected from this age group would get between 5.6 and 6.5 hours of sleep, and between 6.3 and 8.0 hours of sleep? And then finally, I want to know how many hours of sleep will an adult in this age group get if they are in the 35th percentile. So we are going to do this using Excel's formulas. We can do it two different ways. We can make a table, or we could just use the formula. So because Excel is so fast, it's real easy to make a table starting at 0 hours, going by tenths. So 0.1, 0.2, 0.3, and then you just highlight and drag down. Ooh. So now we're at 4.3. Not sure why this is all here from before, but highlight and continue dragging down, because we'll keep going all the way to 12. I don't need that far, but we'll go that far. All right, so how do we calculate this normal distribution? Well, start with equals, and then start typing norm, and there you see the normal distribution function. So now it wants our x, which is just going to be our hours, and then our mean, which we come back up here, and that's 7. So you could either type in 7, or you could type in the B2 and then absolute reference it with that function F4. And then we want our standard deviation. So again, you could type in 1.1, or you could use B3 with that function F4. And the reason I like to absolute reference is because what if we change the mean? What if we change the standard deviation? How's that going to change our probabilities? And then we want this to be true, because we are looking for the cumulative probabilities. And then you can drag it all the way down, or you can just double click. And it really doesn't take long to drag it all the way down. All right, so now we want to see, what's the probability of getting more than 6 hours of sleep? Well, if we find that 6, the probability of getting 6 hours of sleep is 0.1816. So getting at least 6 hours of sleep. So 6 hours or fewer. If we go 6 or under, we're going to be at about 18%. So to find 6 or more, what we're going to do is take 1 and subtract that probability. So it's B71. We can come up here and type in equals 1 minus, and then we go down here and type in, or just type in B71. Hit enter, and we get 0.818, or about 81.8% of people. There's an 81.8% chance that a randomly selected person would get more than 6 hours of sleep. We can also find that by using our normal distribution function if you don't want to make a table. To do that, we're going to type equals and then 1, because we're still subtracting, and then we have to do our normal distribution function, where here my x is going to be 6, and then we've got our mean and our standard deviation and true, because again, we want that cumulative number. And we get the same answer. For this next one, we're looking at fewer than 5 hours of sleep. For that one, we just need to find our 5. since this is an accumulated number, that 0.034 is what our answer is going to be. So we come up here and we type in equals my 5 or B61. And again, we could actually just type it in if we want to. Equals norm distribution. My x would be 5 because we're looking at less than 5. My mean is 7. My standard deviation is 1.1. True. And we get the same number. So again, you can do everything I'm doing with the table, you can do just typing in a formula if you choose. All right, so now between 5.6 and 6.5. All right, so well, wait, before we do the equals, let's go find our numbers. 5, right, 5.6, yep. 5.6, I'm going to color these a different color so that way we know where they are. And 6.5. So we're going to subtract those two accumulated numbers. So equals, let's go find 6.5 minus 5.6. Hit enter, and we get 0.22. Or about 22% chance that someone would get between 5.6 and 6.5. Again, you can do this by using just that normal distribution function twice. So norm distribution, and we're going to start with our x of 6.5, then our mean, then our standard deviation, then true. Close that, and then we're going to subtract another normal distribution. Only here my x is 5.6, my mean, my standard deviation, and true. Close the parentheses, and we get the same number. And we're just going to do that exact same thing again. So I'm just going to copy and paste this. Oops. We're going to go back. I want to copy this, paste it here, and then change my 6.5 to 8.0, and my 5.6 to 6.3, and we get 55. So now let's see if that same thing is true when we go down and find 8 and 6.3. There's my 8 minus 6.3. So B91 minus B74, and we get the same thing. All right, so next, how many hours of sleep will an adult in this group get if they are in the 35th percentile? To find percentiles, we need z-scores. So again, there are two ways that you can do this. If you love Excel, we can start by finding those z-scores back from chapter 3. And that's, I believe, specialization. See if I can find the right formula quick. Let's go here. Now I'm searching for something with an S. Standardize, not specialize. Sorry about that. Standardize. All right, so we're going to standardize. There we go. And our x, and our mean, and our standard deviation. And we are going to absolute reference that mean and the standard deviation so that they don't change. And we close our parentheses. All right. And we're going to drag it all the way down to 12. Okay, so now we need to do another distribution. So we're going to use norm distribution again, but we're going to do a little bit different and use norm.s, so our sample distribution. And you'll see that now I've got a z and a cumulative. So now we're going to put my z-score that we just calculated, and then true, because we want it to be cumulative. and drag that, or double click to drag it all the way down. And what we are looking for is, where does this go to the 35th percentile? So if we look right here, we're not even to the first percentile yet. Oh, right there. Between 4.4 and 4.5 hours, we crossed over into the first percentile. So we need to find the 35th percentile. Happens somewhere between 6.5 and 6.6 hours, because here we go from the 32nd percentile to the 35th. So what we could do is say, okay, we know it's going to happen somewhere in here, so let's go one more decimal place. So let's insert a few rows, do a couple more. All right, I don't want those to be, so let's try 6.55. And all these other rows automatically fill in. So 6.55 is still too low. How about we try 6.59? That's still too high. So it's somewhere between there. Let's try 6.57. That's a little low. 6.58. That's a little high. So somewhere in here, we cross over to the 35th percentile. So 6.57, 6.58, either one of those two would be acceptable due to where it crosses here. If you look technically, I think 6.58 is a little bit closer, but it's up to your discretion. Now, so what we would do is we would just say 6.57, 6.58. The other way that you can do this is to use the appendix in the back of the book. It's table 3. Appendix A, and what you do is you look for, where do you see the closest number to 0.35? So if you look down the first digit of Z, we're going to go down all the way down to negative 0.04, negative 0.03, and if you look at 0.4, we find 0.344, but then if we look at the 0.3, we get 0.348 and 0.342 or 352. Well, the 3483 is the closest to 0.35. So your z-score, or z number, is going to be negative 0.39 when we add the column, the first digit, and the second digit together. We get negative 0.3 and 0.09. So that's going down the side and the top of that table. All right. So then what we're going to do is we type equals. And we are going to look for that mean and add our z-score that we came up with from that table, which is negative 0.39, and we are going to multiply that by our standard deviation. And what we should get is something close to 6.58. Let's find out. 0.6571. So that's telling us that technically we should have used 0.57 instead of 0.58, but that's okay. If you use this way, I would accept either one if you came down and figured it out this way. And that's how you would answer questions based on a normal distribution.